Next talk will be given by Carle Pieters, and she presents work by her and colleagues on the probability of Artemis collecting deep-seated material excavated from SPA to South Pole is tiny unless. So I hope Carle enlightens us, unless what?
I'm trying to get my screen up. Let's see.
Okay.
Well, it's tiny unless, and I'll jump right to my conclusions. A human robotic partnership is established that includes modern instruments, training and site planning, and a robust infrastructure. So I'm sort of the third bump on the log, but I'm going to re-emphasize many of the things that have already been said. Okay, well, Apollo and Luna sampled sites are all on the near side, and there's right now none on the far side. However, the South Pole is about a hemisphere away from sampled terrain, but it will be close to sampling, or it will be the closest sampled site yet to the South Pole Aitken Basin, and might, perhaps can. I'm not as optimistic perhaps as Brad, but if we do it right, I think we can get it. Okay. What should we expect? Well, by now you should have heard both from Jim and from Brad what the basic character of the terrain is. Several years ago, the master, Malash et al. Did a model of the impact itself and distribution of the ejecta. As was mentioned, we believe the impact forming event was oblique, and this has very strong implications of where the deposits go. Okay, where the deposits go in on the moon. Dan Morardi just recently took the Malash model and put that into geologic context as well as composition. And what you see on the right is the distribution of the predictions of where the ejecta from South Pole Aitken would be deposited after the event. Now, most of us are familiar with the South Pole. The most common view of it is shown on the left with the beautiful LRO mosaics that show how deeply shadowed the area is. What's shown on the right is what the LOLA, the LRO LOLA laser altimeter provides. These are both reflected data. However, with the laser altimeter, you can look at the surface without any shadows. You're looking at a shadowless moon, and it looks familiar to you. However, now you're eliminating the shadows in the normal solar illumination, and you can see that, yes, the South Pole is part of this feldspathic terrain that Brad was talking about. Let's look at it in a little bit different perspective. Again, comparing with some of the information we've already discussed. The South Pole is in this vast high albedo terrain, which we know is largely the feldspathic breccias compared to the darker iron-bearing basalt and the interior of South Pole Aitken, very similar to what we have sampled at Apollo 16. And again, showing the low iron distribution as seen in the gamma ray spectrometer data. So this is a completely consistent story, but it's telling us that it's primarily feldspathic breccias and not the, and right now we don't see any of the abundant mafic minerals at all. Well, now samples from the South Pole Aitken, from the South Pole are extremely valuable. They're unsampled breccias with very low creep. We only have Apollo 16 and Luna 20 that provide us information about this kind of terrain. These are extremely baseline important samples to obtain to understand the feldspathic character of the moon. Of course, the reason we're going to the South Pole is we know there are volatiles there, and we're very interested and eager to sample them. How we sample them will be a challenge, but we're guaranteed to, or almost certainly guaranteed to get volatile samples. However, now, and the third is that the samples just might, perhaps can contain some of these exotic components. Even though they don't show up in the albedo data or in the detailed overview that we see. Finding these unusual samples is going to be hard. Now, why is it hard? Even for a well-trained geologist. First of all, and I think you're all familiar with this, that there's very persistent low illumination, deep shadows. Think of going out at midnight on a moonless night, having a spotlight behind you and trying to find your way around unfamiliar terrain. Oh, how hard is that? Secondly, and Brad and I picked the same allegory, looking for these are going to be a needle in a haystack. They're very small compared to the bulk character of the environment. Well, that's where efficient human-robotic partnership are needed, and there are three elements that I want to walk you through to talk about that. First of all, what is human-robotic partnerships? Human astronauts are uniquely adept at assessing environments and adjusting actions to be the most beneficial to achieve goals. That's why we send humans for exploration. However, at the poles, human perceptions are going to be severely limited. In contrast, modern instruments are designed to provide attuned and specialized eyes to provide the information that we really want to see that we can't see with our own eyes. And it's humans and robotics working together that are not only efficient, but achieve results superior to either one of them working alone. Okay, well, there's three elements that I'm promoting. First is modern instruments. There are several sessions in the forum that address examples of some of the modern instruments. What's needed is not only the instruments themselves, but we need the infrastructure that will allow the data themselves to be returned and worked with the planning for what the astronauts are working on the surface. That said, the training and site planning needs to incorporate this in their training. Astronauts and science teams who are familiar with these instruments need to be working together so that they're a well-tuned partnership. Okay, the third and most important, because it hasn't been mentioned and there are no US assets of this currently in place. I was glad to hear the Europeans mentioning this as a goal in their presentation earlier this morning. But what's needed, which is essential if we're going to have this partnership, is a direct communication that includes high bandwidth. You don't want to cripple these instruments by having a low data throughput. You need to have a continuous interaction, a continuous infrastructure link, so that as the astronauts are sleeping, the parties back in the back room can be madly assessing where things are and where the most valuable use of the astronauts' time might be. Second or last, you need two-way real-time communication. The back room needs to be part of this whole package, obviously through appropriate channels, but that's very essential because of the nature of the South Pole and the situation that it's in. So let me come back to my conclusions. If it's not obvious now, after all three of us, the probability of Artemis collecting deep-seated material excavated from South Pole is really small unless a human-robotic partnership is established that includes modern instruments, training and site planning, and a very robust infrastructure. Thank you.
Thanks, Carly. We have about a minute of time here. And I promise to my co-convener we won't eat into your time, but does anyone have a question for Carly? Question in the chat window.
Go ahead, Noel.
Where can we sample representative SPA material within SPA?
Oh, well, okay, Brad can answer this probably better than I can. Clearly, it's going to be a complex challenge, but certainly one that is doable, because once you're in the middle of the basin, you can unravel this impact history. And identify some of the prime areas, you can get the diversity that includes ejecta and subsequent events. So that's a whole nother planning activity. Would love to do it.